I got it this time. Hello, everyone. Thanks for joining. We still have some people coming in. I'm just going to give them a couple minutes to finish get in, then we'll get started. Okay, I think we can get started as we've been fighting with getting the blocks off of Gabe's screen. Um, all right, well, thank you everyone for joining us. Just a couple of housekeeping notes. I'll let Gabe introduce himself here in a second. For those of you who haven't been to a Zoom webinar before, it works a little bit differently than a Zoom meeting. You may have noticed that you are all muted, for example. If anyone has a question, basically got two options. You can hit the raise your hand button along the bottom, and what that'll do is I'll see it in this list that you have your hand up, and then what I'll do is whenever Gabe has a pause, I'll just let him know there's a question, and then I can unmute you. What you can also do, there is towards the bottom a Q&A button. You can bring that up and type in a question. That'll just add it to like a list of questions, and we'll go through those at the end of the session. That also gives others the chance to like upvote your question or to add their own comments to it. But with that, I will hand it over to Gabe.
Hey guys, can you guys hear me? Paul, I guess you're the only one that can respond.
Yeah, you sound good.
Cool. Nice to meet you guys. My name's Gabe Van Solkema. I have been working with Configura now for almost 5 years. I was an intern for 2 years, and since then I have been an application developer for the past 3 years. The bulk of my experience is working with Office extensions. I've worked with a bunch of different clients, and I've also spent some time working on the FICA Office extension. If you've had a chance to check that out, that's our example extension. But yeah, just a little bit about me. And today we are going to be talking about CM unit testing. I'm really excited about it. I think it's something that is a long time coming for the CM language. And I think it's a tool that you guys are really going to be able to take advantage of. So the order of operations, I'm going to be talking about unit testing in general. So what is unit testing? Why would you want to use it? Where is it already used in the world? Um, and then I'm going to talk about, what is CM unit testing? So what's different about our CM unit testing when it comes to, relative to the rest of how unit testing works elsewhere? Um, when should CM unit testing be leveraged? So when is this something that you guys might want to take advantage of? And then obviously, how do you use it? So how can I actually go ahead and implement CM unit testing in my code? So what is unit testing? It's an automated testing tool used by developers all around the world. It it's used in many, many languages and many different development environments. And it allows for tests to be run on code to ensure that you're getting consistent results. So given a set of inputs, you want to make sure that your outputs are producing the results that you would expect. And so CM unit testing is a way to ensure that your outputs are always going to be consistent. Uh, and this is a big one. Unit testing is a way to ensure that things which had been working before still work after new changes. So if you've been on a project before where over time the code just grows and grows and grows, and then there's more features and more functionality that gets added over time, requirements may change, products may change, and you find yourself breaking certain things that used to be working before, or we're trying to make some small change, over in this section of the code, only to find that your small change affected something, um, or had an unintended consequence elsewhere. Unit testing is a really good way to catch those instances where your code may have changed, um, and it may have affected functionality that you did not expect. And so unit testing can kind of come alongside you while you're making these changes, and even while you're developing new things, to make sure that um, things are actually working and that you didn't break something. Because I know for me, speaking for myself, obviously no other developers ever do this. It's really easy to make a change and then not realize that your small change actually has some greater consequence elsewhere that you did not expect. So unit testing is a great way to make sure that things still work when you're going around and making a bunch of changes to your code. So how does it work? It works by testing individual units of code. So unit testing, you're going to try and break down the code into small, you're going to try and break down your tests into um, testing small units of code. And each test should be unique, and it should test like a small chunk or functionality in the code. So I'm not saying it's going to test only one line, but it might test, a function or a method, or a small combination of these things to make sure that um, your code is working. Uh, and you can combine these things a little bit, but you don't want your test to become too robust. The point of a unit test is for it to test a concise, scoped chunk of functionality. So it is a debugging tool, and oftentimes with debugging tools or testing tools in general, uh, us developers don't have a lot at our disposal. We kind of write code and then we have to go in and manually go around and test things, and make sure everything still works. Or we rely on testers to do this, or worse, we rely on the users to test our changes, and then obviously they get frustrated when things don't work. Um, but unit testing is a great debugging tool for developers. So it's designed to be used by a developer, and it exists independently from the rest of the code. So writing your unit tests, if you were to write a bunch of unit tests, it's not going to affect how your code works. They exist independently, and it's not going to slow down your code at all. It's something that you're going to run when you want to run it, um, and it will not affect your runtime environments. So you could have, thousands of unit tests. Preferably, those would be in some sort of test folder, organized in some way. But you could have tons of unit tests, and those unit tests wouldn't actually affect all the other code that you have written for your extensions and all your products and all your functionality. So it's scalable based on your debugging needs. I think this is important. Depending on what you need, you could find yourself running into situations where you want to implement a bunch of unit testing for a certain chunk of functionality. Or you might find yourself saying, hey, this isn't actually something that I really need to unit test, or at least I don't feel like I need to unit test it now. And so we're only going to have a few unit tests on this small subset of code, just because it's something that should work, or it's something that is niche and isn't affected by a lot of other things in the code. But as a project grows, more and more things are implemented, and it is hard to know how everything's going to affect everything else. And so it's a good idea to write unit tests as you're writing code. So you should be writing unit tests as you're writing new features. And this isn't just to make sure existing working code is not broken. That's what's written here, but it's also to make sure that while you're writing things, the things that you're implementing, new things that you're implementing work. So you can use the unit tests to actually debug new development, as well as to make sure you kind of are like locking it in, making sure that this thing works forever, hopefully. Um, Tests are ideally written for new features as they're implemented. As I said, it's hard to go back and write a ton of tests for something that already works, especially when you then need to refresh yourself on all the rules and make sure you're up to date on all the requirements. Whereas when you're developing something for the first time, something new, you're very in tune with what you're trying to accomplish, and you're going to become acutely aware of all the obstacles you face as you're engaging in that new development. And so ideally you write tests as you develop, and the tests act as almost like a way to help you develop this new thing, to make sure even while you're developing this new thing that I'm not breaking certain portions of it as I expand upon its functionality. But you can also then lock these things in and make sure that in the future when someone else comes along, they don't accidentally break this thing that obviously you spent a lot of time on making sure that it works a very specific way. So what is CM unit testing? So this is built into the CM language syntax. So this is new as of 11.0, I believe. So this is something you can actually take advantage of right now. And what you can do is you can go into the CM language. You can actually go into your CM code and implement unit testing within CM, which is awesome. We've needed this probably for a long time. And there were ways you could do individual tests and small tests. You could run methods and sort of kind of build up your own version of unit testing if you needed to in the past, but we now have a much more standardized way of doing this, where you're going to be using classes and methods, and it's much more robust and easy to use, which is good. And this was inspired by the industry standard XUnit. So if you've never heard of XUnit, it's basically it's kind of like a unit testing paradigm. It's like a bucket where There's tons of different unit testing standards and protocols out there, and XUnit is probably the most popular one. If you've ever heard of like JUnit testing or RUnit testing for Java and R respectively, those are both XUnit. Those both follow the XUnit paradigm, and that's what CMUnit is doing as well. So it's meant to be used by developers as they write code to help with current future debugging. And then we'll get into this a little bit later, but there's a T-script object that you're going to use while you're writing your unit tests. And it's super, super helpful. And it'll help you write all your tests, and it'll simplify that process a lot. So when should you be using CMUnit testing? It should be leveraged as needed. I should have put that in bold, as needed, across functionality to ensure that things work as intended, both initially as you write them and in the future. And when I say as needed, I think that's something that, from like a philosophical perspective, when should you be using unit testing? There are a lot of different approaches to this. There's a lot of different thoughts on this. Some people think every single method on every single object should have a unit test to ensure that it works a certain way, or maybe every single method that returns something should have a unit test to ensure that it's always working. Some people think you should write unit tests for only for the things that get to a certain level of complexity where they're easy to break, or there's a lot of moving components, and so they want to make sure that functionality is locked in, so that someone doesn't come along and accidentally break something complex. There's a lot of different philosophies when it comes to when to use unit testing, and I think that as needed is key. I think different projects, different scopes of functionality are going to require different approaches, and this is something for the team to decide, whether that be your PM or whether that be a senior dev, or whether that just be anyone as they're implementing things. Some people are going to feel more comfortable when there's more unit testing, and some people are going to say, I don't really see the need or feel the need to ever use unit testing in this specific situation. So I think it should just be leveraged as needed, and that really just depends on the use case and the project you're on, and the products you're implementing. But as far as specifically when it should be leveraged, it should always be leveraged in situations where a set of inputs should require a specific output. So you're not necessarily going to be using unit testing to test for like crashes, or to test for this ginormous chunk of code that's doing a bunch of different work on a bunch of different objects. Really, you want your unit tests to be isolated, and you want them to be testing situations where there are a given number of inputs and they have a constrained number of possible inputs, and those inputs should elicit a certain output. And the different inputs could maybe affect that output, but you want to make sure that the output is what you would expect it to be. That's, I think, from a philosophical perspective, when to use this, that's the time to use it, when you have a bunch of inputs that should require a specific output. And CM unit testing can be used to ensure that a method or a function that takes an argument is returning an expected output. So if obviously we all know how methods or functions work. You have arguments that you take in, it does a bunch of work, and then it might return something. So in these sorts of situations, it makes perfect sense to use a unit test, because you have a bunch of inputs coming in, you expect some things to happen, and then you expect some sort of output, whether that be some chunk of code running and doing something. You might be able to check the state of something after this happens, or if you're returning something and you have an expected return output, that would be another great case for unit testing. So let's get to CM unit testing. Let's actually talk about how to use it. So you're going to want to make sure that you have visibility to a few packages. You want to make sure that they're included in your scope. So the three packages would be cm.test, cm.test.cmunit, and then cm.test.tscript. And the tscript guy is going to be like your helper buddy. I kind of mentioned him earlier. I'm going to walk you guys through why that third one is so important, because you're going to definitely use him to help you guys when you're running your tests. You probably should create a new folder for your tests. I say this just to stay organized. So you could do a subfolder, just like a test folder in your package. So let's say you have an extension package. Let's say, for example, it's abstract office. So you have your abstract office package, and this, you could then have a subfolder, like a test subfolder, and then you could then have all your testing files in there. Otherwise, your main extension folders, your main package folder is going to just become very, very, depending on how many tests you write, obviously, it could just become very disorganized. So I always think it's a good idea to make a new folder for your testing. And then you should just create a new file, whether or not you've created a new folder or not. And inside this file, you're just going to create a new class that extends off of test case. So we're going to get into some code in a little bit, but these are just some things that I kind of wanted to harp on. This is coming from the core guys who wrote this, and this has to do with just organizational standards, as well as it'll make your life a lot easier. So you're going to have a test case class, and then you're going to have the actual method for your test. And it's suggested for there to be just one test case method per class. That way you can isolate your testing, because when you run your tests, you can actually run tests on a whole file or just a given class or even a whole package. So if you've isolated your tests enough on a per class basis, you can actually run these tests, kind of pinpoint them, and actually run the unit tests that you need to run without running a bazillion other ones that are unnecessary for your given use case. It does make sense, I think, in some cases to have a few tests per class, and this might be, when you have a situation where there's a bunch of things that are closely related, a bunch of functionality that you don't want your unit tests to be testing a giant chunk of code, like I said. So if there's 6 or 7 different chunks of code that are all working together and they should all produce certain outputs, it might make sense to group these tests together and then always run them together. That's a situation where you might want to have more than one method per class. But again, then you're no longer isolating these tests. They are always grouped together. And then to run your tests, you can use, these are a couple of the commands. There's actually another one for testing an individual class, but you can test a file. So, you may have a file with a few different test case classes, or it might just only have the one class. And you can run a test file. You can run the test file command, and it'll just run all the tests in the file, it'll scoop up all the tests and provide you feedback as to whether or not they passed or failed. And then you can also run tests on a whole package, which is super useful if you just want to make sure everything works, or if you just want to make sure that your code is in a good state. And you're going to want to do that by having the symbol, pound key, and then your package name inside of quotations. So when you actually run these tests, regardless of how you're running them, you're going to see trace to note how many of your tests have passed or failed. And the ones that failed, so the ones that passed are just going to pass, and it's not going to give you much feedback, but that's obviously a good thing because they passed. The ones that failed are actually going to provide some trace to say, hey, this test specifically failed. And I think that's why it's important to isolate things, because it does help you trace out which test exactly was the one that failed. And it'll give you, I'll show you in a little bit when it comes to the trace, but it'll give you a lot of information as to like, what was the output? What was the expected output? Why did it fail? Uh, and that's really useful, obviously. And then the isolation of your test to narrow and concise scope will be crucial, because if you don't have isolated tests with um, a very defined and concise scope, your tests could be failing due to a number of reasons. And that's why it's so important for your tests to just um, be super clear. Like, hey, this is a test that's testing this specific thing, and I'm expecting this specific output. And if I don't get it, then I know exactly what's gone wrong, as opposed to like cramming a bunch of functionality in one test, and then at the very end testing to see if your state is right, but then not knowing where along that functionality your state got into a poor state. Um, so it's important to really isolate your tests and make sure they're concise in their scope. Um, and this is another big one, and this is, I think, back to kind of like the philosophy behind using unit testing. Tests do have to be maintained. If your requirements are changing or your functionality is changing, or just your desired outputs after, like I said, you've got a set number of inputs, they should be producing a given output, and let's say that that output no longer is what it was before. The output should be something different. Maybe your data is changing, or maybe the domains are changing, or your products are changing. Um, for these tests to be useful, you need to maintain them with requirement changes, and I think that uh, that does lend itself to extra maintenance. And so it's something to definitely be aware of, because if you're implementing new things and then you're also going through and writing tests for all these things, you have increased your development time for something. And then down the line, let's say this thing changes, as things often do, you then need to go back, and for your tests to be useful, you need to go back and make sure that your tests reflect the changes that have occurred, uh, whether that be requirements or whatever. And so there is a level of maintenance when it comes to these tests. However, they can save your butt big time when it comes to just accidentally breaking things and making changes that you think for sure are exactly what you wanted and are going to solve this bug that's been annoying everyone since the beginning of time. And then you go in and you fix it, and then like 3 weeks later, all of a sudden, there's a bunch of new bugs that popped up, and you're like, well, these things were working before. And it becomes a bit of it's like whack-a-mole. You're like, oh, I solved this bug, but then there's a new batch of bugs that popped up. And a lot of times that has to do with making unsafe changes and breaking things that were working before. Uh, while valiantly attempting to solve this one bug over here, you're just creating new bugs elsewhere. And so I think that's when unit testing really is valuable, and it is valuable even with the maintenance that comes along with it. But it is like an as needed thing, and it's something that you guys can decide for yourselves, like, hey, this makes sense to unit test, or hey, this actually doesn't make sense. So I'm going to talk about this tscript object, and this is the guy that actually lives on the test case base class, and it's super useful. And you're going to be using it to write all slash most of your tests. I think most of your tests, if not all of them. Um, so what does this tscript object do? So obviously you're going to be extending off of test case when you write your own tests. And so you're going to be given access to this object that lives on the test case base class. And what it allows you to do is grab objects out of space. That's super important, so that you can actually test the things that are existing in the drawing. You can copy and paste snappers. You can undo, redo. You can load and save drawings. You can insert, you can remove snappers. You can just do a bunch of different things that are going to allow you guys to really test the state of a given drawing, or test the state of snappers in space. The biggest thing that T-Script does is it gives you access to space. And once you have access to space, you have access to all the things that are in space. You have access to the world, and so that's really important. So actually, let's get to some code here. Can you guys see my screen, Paul? Just want to make sure.
Yep, you're good.
Cool, cool, awesome. So as you can see, here I am down in Abstract Office. I made a little test folder. Like I said, I think it's good to do this in order to organize your code. I'm making sure to use these three packages, cmtest, cmunit, cmtest, tscript. And this gives me access to a bunch of unit testing functionality. So for starters, I have a class called basic test, which extends off of test case. And I think it is worth going down and showing you guys what this class is. This class is down in base CM test CM unit. It's an abstract class, so obviously you're going to need to extend off of it. But what it does is it has this guy, which is your T-script buddy. You're going to be using him to write your tests. And then it has some other things that are useful. A description if you want a description for your test. You've got some hooks in order to, you see, you've got some things that you can use in order to help set up your tests. So you have init all, init, tear down all, basically a bunch of things that you can hook into, after a test is called or after all the tests are called. I'm not going to get into some of these functions down here, but these are basically the code that is used to collect the test cases and actually run them for a given file or for a class or for the whole package. So yeah, we have our basic test class that extends off of test case, and then we have our method. What's crucial is that the method actually begin with the characters TEST, test. I thought it was underscore, but it's TEST underscore, but it's not. So you can just go ahead, use your normal camel case syntax, and in this case, I have a basic logic test that I'm going to use to kind of show the very basics of unit testing, to kind of show what's happening. And then from there, I'm going to show you guys some stuff, some tests that I'm running on the Fika Office extension. So the first test, syntax, again, you're going to want to use TEST space. This keyword's important because this is syntax that's being read by the compiler. And in this case, we are going to check if 1 equals 1. And we're going to check to see if this equals true. You also can do something like this. I believe, just to test if 1 actually is 1. But this is more of a, this is one of those situations where if you're trying to check to see if something actually equals something else, and then you're expecting some sort of Boolean output, you can use this. So both of these tests should run and produce the same results. So let's go ahead and run this. And you'll see down here, you've got this little test suite log. We have 2 tests here, this guy and this guy. No failures, no crashes. It ran super quickly. Just a heads up, if you don't know how to run a specific file, you can do Control-Alt-Space. That'll actually run a specific line is Control-Alt-Space. So that'll run this line of code. If you want to just go ahead and run the file, which will run everything inside of this guy, You can do Control Alt P, I think. Maybe not.
You'll have
Maybe
to
Paul.
uncomment that line.
Oh, duh. All right. There we go. That runs the file, Control Alt P. So I'm just going to be using Control Alt P. I'm not going to keep scrolling down. It's a little bit annoying. So just a heads up, I'm running the file, the whole file, when I'm running these tests. So to show you what will happen when something obviously is going to fail. So we all know 1 does in fact equal 1. And so if our expected output is false, this will fail. And as you can see, it gives you a little bit of feedback here. It says that this test, 1 equals 1, where we expected false, we didn't get false, we actually got true. So this test failed, and then you can see here we have a failure. So 2 out of 3 tests passed, but the third one did not. Let's just uncomment that because we don't need to see that. Here's a couple other examples. 1 + 1 = 2. 1 × 3 = 3. Here's another one where I'm testing to see if this string hello world contains hello, which obviously it does. So that's a stir contains check. We'll go ahead, run these just to show you that all of these tests are running and passing. And then this is actually important. So let's go and take a look at this T-script guy. So if I go back up into test case, this class here, you're going to see that we have this T-script object. And the T-script object gives us access to space. And that's, like I said earlier, this is the crucial thing that it has, that it allows it to do. It allows it to do a ton of different things for you in your testing. So you can grab space, you can grab the world, you can grab paper space, you can flush, you can load, you can save, you can just do a bunch of things, favorites, papers, undo, redo. These are actually really important. You can grab the selection. So yeah, this copy, paste, grab a bunch of snappers based on their class. This is going to be this T-script buddy that you have down in the test case base class is going to be what you're using to help you write all your tests when it comes to real world unit testing. A lot of the times, these tests, they don't really do much for us just because if these things are failing, then we have massive compiler issues and we can't actually, rely on any logic really. So a lot of the times we're going to be testing things like methods or functions or running tests on snappers, components, animations, whatever it may be that are real world production code. And these things, might actually break. So we need to make sure that they're working. So to show you that our T actually does have access to space, we're going to make sure that T dot space does not equal null. So we want T to actually have access to some space object. When I go ahead and run the file, you're going to see that it does actually have access to space. So that's actually, this is the biggest part when it comes to the T-script, is that it has access to space and allows you to do a bunch of different things with space. So let's take a look at some tests that are a little bit more real world. So here I have a panel frame test case insert class. It's going to extend off of test case. And in this situation, we are just going to test and make sure that a panel is being inserted into space. If you guys know what a panel frame is, I'll show you guys. So this is just a snapper, and I'm using the Fika Office example extension. And panel frames are a little bit interesting because a lot of times they automatically insert other snappers while they're when they're being added to space. So they'll actually create like a left and right junction snapper as well. But these guys, these panels are basically, it's just another snapper in the hierarchy of it extending off of classes. So what we're going to do is we're going to grab the space using our tscript buddy. If we don't have space, we might as well return. But as I showed you guys earlier, this guy does in fact can grab the space, and it shouldn't fail here ever. Here we are. We're going to create a panel frame. We're going to do a space dot undoable insert using the space that we grabbed off of our tscript object. And then we're just going to go ahead and insert the panel, and then we're going to test to make sure that the panel space is also the space that we have access to up here. So this is basically a check to say, hey, panel, are you in space? So let's go ahead. Let's run this. Oh, I need to do this. Let's make sure all this other stuff is uncommented, or commented out, sorry, I should say. So this panel, it looks like it did actually get inserted into space, and our test passed. Now, this is something I want to draw attention to, this t.undo. This is so important because what we did here is we did an undoable insert on our space. So we're inserting the panel, but we're making this insert operation undoable so that when we go ahead and actually run an undo, and again, you'll notice that we're using T to do this. So just like we grabbed space using our tscript object, we're also going to undo using our tscript object. If I didn't do this, we'd actually have inserted this panel frame into space, and while we could undo it ourselves, here I'll go ahead and do one of these so you guys can kind of see what's happening. So if I run this, you're going to see this is not normally how a panel is created. There's a lot of other things that go into making a panel object, so this panel's super wonky. And while we can undo it, we're going to want to make sure that we're actually undoing within our test case, so that after we've run our test, at the end of this method, it's going to go ahead and it's going to undo this undoable insert. So we go ahead, we run this test a few times, why not? And you'll see that the space, or the panel is no longer in space. And then down here, I'm going to go ahead and comment this. Actually, I'll just leave it in there. Why not? I used to have a nifty, I don't know if you guys attended Caleb's Emacs presentation, or maybe that's coming up still. Paul, has that one already happened?
That was right before this one.
Oh, nice. Well, there's like a super handy thing you can use that it's like a keyboard shortcut that allows you to uncut these things, cut them back in and out. I don't have that anymore. So I actually have to go and remove the lines manually on the top and bottom. It's super annoying. But anyways, here is another test I've written. This is just going to test the panel's width stretching capabilities. So this is actually going to simulate stretching the panel during a width stretch animation. And again, here's what's so important. I actually am telling the space to record this whole, whatever's happening in here for undo. As you'll see, I'm beginning the undo step, beginning the undo recording, and then at the end, I'm ending this recording and then actually undoing to make sure that no matter what I've done in here, everything goes back to normal after the test is ran. So in this situation, I'm actually relying on a panel frame to exist in space. So I'll go ahead and add one. So we have our panel frame in space, and it's going to go ahead, our t.space.snappers, because again, our tscript guy has access to space. Space has access to the snappers, so we can loop through the snappers in space, grab all of our panel frames, and then for each panel frame, we're going to go through its width domain. We're going to go through each width in the width domain, and we're actually going to, I added this little check to make sure it was greater than 0 because I have no idea why you'd ever, I just kind of safeguarded here. I don't know why you'd ever set your width to 0. But we're going to go through, and there's this method on panel frame, which does a bunch of work. If it'll actually, if alt I will work. Sure. Oh, gotta reread. So yeah, this method is called during width stretching. So if you grab your panel, go like this method is going to get hit for each new iteration of your of the width that's being set during a width stretch animation. It's going to assign the width. It's going to do a bunch of work. It's going to make sure that your this method also is in charge of making sure that your work surfaces stretch with your panel, like so. But yeah, we're going to run some tests on this. Actually, one specific test. You could test more. You could do stuff like I just showed you with the work surface. But the test I am running is I'm going to check that my panel's width was actually set to the width that was passed into this method. So I'm calling this method. I'm passing in width to set. I'm giving it a modify env. And then I'm testing to see that my panel's width has actually been set to the width that I was expecting it to be set to. So if I run this guy, I'm going to get 8 passes, which, as you can see, while I'm width stretching, there are 8 different widths available. Actually, there was 7, but this test also was ran up here. And it went through each test, or each width, sorry, and it tested to make sure that the width that was attempting to be set was actually set. And then afterwards, we undo this, all these different things that happened, and we get it back to the state it was in prior. So no matter what I do, the width of the actual panel isn't changing. If I didn't do that, you'd see some craziness. Actually, that happened to be the last width. But you'd see some craziness. Is, you probably don't want to affect the state of your drawing, so it's always a good idea to undo your test results. Oh, yeah, let's look at this really quick. So this is to test the file. This is to test a specific class. So in this situation, we had 8 tests because that included both this test case class as well as our insert test case class. If we were to go back and run the file now, you're only actually seeing the one test for the insert case. So this is a good way to isolate your tests. And then if you want to run tests on a whole package, you can. And this actually included all the tests from this file as well as all the tests from our basic test. So if I uncommented a bunch of these, and then I went back into this file, ran the file, you'll see that I had a failure, which was that 1 equals 1. Obviously, it does equal 1, so this guy failed. But you'll see that it actually was able to scoop up all the tests from the package, both the files that were in the package that I showed you, and run all the tests. So yeah, these are a couple examples that I had off the top of my head. You could probably think of some other ones to run, and it might be a good idea to kind of test out for yourself, no pun intended, when it would be a good idea to use a unit test. But basically, this is what you're going to want to do. You're going to want to set up your classes, you're going to want to set up your methods, and then you're going to want to go ahead and set up your test cases within the methods, and make sure that things are functioning as you would expect them to function. So, do we have any questions?
We do have a couple of questions.
Cool. I should like try and figure out how I can see. Oh,
I'll
cool,
just
I
read
can
them
see
off
it.
to you. That's fine. Right. So first question. If we integrated a collection of test cases into a GitLab job, would fail tests cause the job to fail by default, or would we have to write our own code to make those fail tests crash in order to cause the job to fail? So I think we're talking about like GitLab, pipelines and runners and stuff.
Yeah, so if you were to integrate your test cases into GitLab, um, uh, now there isn't like a default way to do this as of now, although I do think you could set up like a pipeline in order to run certain tests. For example, let's say you have an extension and you want for that package all of the tests to always be run every single time you're going to do a merge or something along those lines. You could probably set up a pipeline in order to make sure that the tests are actually passing. Now, I don't know if you could actually block the merge from happening, but you could make it so that uh, you're running all of these tests so that the person in charge of merging is aware of when the tests are failing and then kick it back to you to let you know basically, hey, you actually broke something in attempting to fix this. Um, and that also might be something that the developer, the people who are actually developing, they might want to be running these tests as well, like as they're working, to make sure that they're not breaking things as they go. Uh,
Does unit testing have a log functionality built in?
I'm not sure. I don't think there's actually, when you say log functionality, are you talking about uh, like tracing things out, like having the ability to print things out?
I'm guessing. So we already get like those printout to the compilation buffer. I'm thinking this means like sending it out to a log file or something.
Yeah, you could probably have there's nothing built in as far as I know, but you could make sure that you could write code to make sure that uh, your results are being exported to some sort of text file or something if you needed it to. And that's actually a good point. Maybe that's something that's worth bringing up with the core team in case you've got situations where you're running so many tests that it might make sense to actually uh, export those to some sort of document in order to read those or provide a report to someone. So that's a good point. I don't think there's anything built in as of now, but that's something that uh, we could contact core about and see what they think about adding that.
Something I can throw in there, getting back to like the GitLab runners question. I'm pretty
Yeah,
sure those GitLab runners do catch console output just as one of their artifacts. So at least there, I think you'll get it. But if you want it, if you're running it just on yourself, yeah, it sounds like we're still debating on how to do that.
yeah, yeah.
All right. Is there a way to test data-driven catalog-oriented snappers?
Yeah, I would argue those are the ones that you'd want to test the most. You would want to make sure that after things happen, that your data is good. That's to me is a huge use case for unit testing. And really, what you're not limited in the tests you can write. So uh, you could test to make sure your data's option code is what you would expect to be, or you could make sure that your data's root code is what you would expect it to be, depending on how your data is set up. But yeah, you're really not limited in how and what tests you write. And how you write them. Really, you just want to be writing tests that are checking for some sort of state, and so you could be checking to see is my data in the state I expect it to be in for a given snapper. And then I see there's another one. Is there a way to test if
Ah,
snappers are connecting? Yes. What you can do is make sure that you'd want to align the snappers based on the connectors that should be connecting. Um, and there's a lot of align code down in connector and snapper to make sure that your stuff is aligned, and you can forcibly make things aligned too if you want to test that. And then you would just run, there's a few methods that you can run in order to actually connect these things. For example, um, snap all aligned is one. You can call that on your snapper to make sure that all the things it's aligned to are actually connecting. And then you can go through your connectors and test to make sure that you're connected to the thing that that you'd expect to be connected to.
Okay. When testing fails and the expected result is in a variable, I experienced that the expected output was not printed, only the resulting value. Is there a way to affect the output in a simple way?
That's a good question. When the testing fails and the expected result is in a variable, experience that the expected output was not printed. Interesting. I'd be curious what it's actually doing there. But all of this code is, all of the output is generated via the syntax that's down there. So you could modify that, but I wouldn't. I would say for now, if you are testing to see if the expected result equals a certain variable, and it's not explicitly saying what that variable is, I would set that. I would actually get that variable's value out of it somehow. That's a tough one. That might be something we need to go back to the drawing board, because you should be getting the expected output there, and I don't really know how you'd get that expected output without it showing what the variable's value is. What do you think about that one, Paul?
It might be nice to be like able to trigger like an inspect or something on a failure, maybe.
Yeah,
Well, I
yeah,
guess not an inspect, but maybe like yeah, just like a short stack dump or something, just to print out all the values on that object.
yep,
Optionally, of course.
yeah.
Okay. Is this something that could help with testing scenario-based situations like support generation?
Yeah, I would actually argue that that's would be a huge use case if you have a support system, and especially if the support system is attempting to automate support placement. You could write a ton of unit tests to make sure that the supports you would expect to be there are actually being generated and are actually where you would expect them to be. That to me is that's how, from my perspective, that's when I would use unit testing. When you've got a complex chunk of code, maybe you've even written like debug trace helpers, so that whoever comes along next, because it's so complex, is going to actually be, they can turn on some debug trace to see what's happening. But it's these complex things that are so easily affected by other things, that are, almost like algorithm based, where you have an input, which might be like, oh, I've got a work surface of this width, or um, storage of this width, or I have 3 work surfaces next to each other, or I have work surfaces slash storage in like some sort of L configuration. And you know exactly what the output should be, but you want to lock that in and make sure that that output's always being generated. That's the type of situation where I think unit testing is really useful. That's when it's really valuable to make sure that all of the situations you may encounter um, are testable, so that someone comes along and they make a small change, or requirements change, and now your everything else is still working. They might only need to change 1%, the other 99% still work, and it'll help you as you develop too. Documentation, actually, I'm not entirely sure on that. That's a good question. uh, Paul, what do you think about documentation? I know the wiki is depends on if someone's actually updated the wiki. I can give you guys access to this presentation, which might help. Um,
I would
but I don't know.
expect if we have, because this is a newer thing, it's likely in one of the new help articles.
That's my guess too. Now, I wasn't aware of this until a couple months ago, and I learned about this via hopping on calls with people, so I wasn't able to locate this documentation. which was actually a little bit frustrating for me. And I'm sure that would be frustrating for all of you guys as well. So I can get with the guy who wrote this. He's actually one of our top developers over in Sweden. I'll make sure that he can either get some documentation live if it doesn't exist, or make sure to send me some sort of link if it already does. And then how can I get that to people? What's the best way to do that, Paul? Are we providing like if I added it to this PowerPoint, are we giving them access to my PowerPoint after all of this is said and done?
I believe we are going to publish all of the PowerPoints.
Okay.
Alternatively, briefcase post might be a good option too.
Yep. Yeah, that's what I was going to say.
Okay. Does the test suite create persistent test reports to keep results from test execution? For results, I mean like what tests ran, what inputs, expected outputs, actual outputs, results, yada yada.
Where is this one? I'm not seeing.
I'm not sure what you're seeing. I've got it up.
Maybe give me it again then. Oh, does the test suite create persistent test results to keep results from test execution? So there are ways to actually, so you can make sure that certain things are ran and certain things aren't ran. But really right now we just have the test file, the test class, and then the test, the whole package. So I don't know if that answers your first question, but as far as testing reports goes, like I said, the trace is there, and if you wanted to export that to some sort of log file, I think you could. Parameterized tests, there aren't as of now. That's something actually I asked about. I'm curious whether or not this does end up happening. I think it should exist, but then at the same time, you can probably achieve the same thing just by writing more tests. The question then becomes, well, how many parameters are we dealing with? How many different paths of logic could we go down in that sort of situation? How many tests are we trying to write? I can see where, like, if you're just writing a bazillion test cases that are all testing like one parameter difference, it could get really frustrating. I would wonder then if you'd want to use some sort of looping functionality just within the one test method. And then, what would the feedback and trace look like? Not entirely sure, although it should give you the variables that are failing. So, yeah, parameterized tests don't currently exist, although I can see how that would be useful. I think you can work around it for now, but yeah. And then, are there any ways to print test metadata? So there is the description, but the summaries are basically what you see, the test suite log file or the test suite log. And then there will be some sort of, there is a description you can add for the test. I think it's like so, okay, I don't know. I think, well, you can always go down and change some of these things if you really wanted it to. If you really wanted to, you could also add trace if you really wanted to your tests, although this could become jumbled. I don't think there's a way right now, because this is relatively new, for you to like go in and modify how everything is output, although I can see how that would be super, super useful. And that's something I can get with Hampus on just to see where he's at on that one. But I think right now your output is pretty locked in. It's just going to tell you what's failing and what's passing. And if it's not passing, here's why, and here's the thing that isn't passing. And then, yeah, when it's not, yeah, I can see how it would be really useful to see, like, hey, given these inputs, I expected these outputs, and here's, what didn't happen. If you set your tests up a certain way, you should still see these things. But again, now we're looking at how many tests are we writing, and how many different test case classes or methods do we have, and how are we organizing things. I I think that having parameterized tests along with having outputs that actually tell you what the inputs were that led to said failure, I think that could be really useful.
Just want to jump in. We are over time already, so we do need to wrap it up. I'm going to say, well, real quick, I just want to thank everyone for attending and give us your attention. We really appreciate it. We're going to stick around for a few minutes. We'll try and whip through the last of these questions. But for those of you who are trying to get to the next of the sessions, just say thank you very much for being here. Enjoy the rest of the experience. But for those sticking around, let's see if we can whip through these real quick. Is there an easy way to test doing an insert through an animation? I don't want to guess what core is doing, but an easy function that simulates inserting via a library, for instance. Well, I would like to test more than just an undual, but insert. I feel like the place snapper function might be what you're looking for.
Yeah, the place snapper or yeah, that's tough. Obviously, just because of the animation is going to require so much with the mouse, and it's going to affect the whole state of the animation and everything. So that's an interesting one. Yeah, maybe the place snapper functionality.
I guess it really depends on what you're looking
Yeah.
for on top of just undual but insert.
Yeah.
To actually simulate, an actual click on the insert, the button, and then dragging the mouse to the drawing and then placing it. There'd be a lot of work to do there, and it's hard to say how much of that would actually be useful on top of actually just placing a snap. So it'll just depend on what you need.
Yeah.
Can these tests be configured to run automatically by Build Center? They should be. So Build Center, you can provide test scripts, those test XMLs, where you can point out like a specific function, and it'll just run that function. And since you can invoke all of the tests via function, yeah, that should be pretty doable. Does that sound right, Gabe?
Yeah, I think you should be able to. I talked to Hampus about this. He said that there wasn't like a super easy way to do this as of right now. But I think he basically said exactly what you said. So it's not going to necessarily run it. It's not going to like search for these files on its own and run through them all.
So you would just include it in that XML file to tell it what to run.
Yep.
And last one, any chance we could get some Fika examples in the documentation? That's a good idea.
So there actually are examples already existing down in the code, and I think it has to do with I can't remember what. Now I want to find it because that way you guys could see. Actually, let's see if there's any.
Keep in mind we're down to minutes before I have to cut it off.
Nope, that's not one. There's one I think in the X clip. Where's X clip at again, Paul?
Oof, I could not tell you.
I can't remember either. I'm doing it. Let's see if we can find it before we run out of time.
I do like the idea of maybe putting
a few
some
of these
stuff in Fika. There's definitely some stuff in there that are worthy of unit testing, like automatic supports, like you called out.
Yeah, because you could write a ton of them just to make sure that all your supports are generating as you expect them to. This is just not. I can't remember where it was.
CM Core X Clip, apparently.
All right.
Andrew's got our backs.
Nice. And then I think there's some CM unit stuff in here. I think this guy. So this class, this is an example test case class. And this is actually much more robust. And so this would be a great example for you guys to use. I really wish I had shown this to the guy who asked earlier. I hope he's still on the call. This is down in core, CM core S clip test. And here you'll see a pretty robust test case where you've got fields. They're doing stuff with the description. They're initializing things before the test. Um, for example, they're switching to paper space. Um, and then
Okay,
they have a
we
bunch of
are,
tests they wrote. So,
sorry to cut you off, but we are
no, you're good.
actually fighting with another session at this point. So
All right.
I'm going to shut her down. Thanks again, everyone. I
Yeah.
appreciate the time.
Bye,
Enjoy the
guys.
experience.
Thank you.